Hi everyone, I am SURESH. I am doing as a math senior lecturer in Narayana Group. Now I would like to explain the concept sets for the students. What is meant by an object? Object means in our mathematical language, in the universe, everything which is living or unliving thing is called an object. And what is meant by a set? Set is a collection of well-defined objects is called a set. The objects are called the elements or the members of a set. What is meant by a well-defined? Well-defined means the process, the possibility which is to determine is called a well-defined. Well-defined means suppose all the alphabets in an English language, it is well-defined. The set of all positive integers is well-defined. The set of all prime numbers between 1 to 10 is well-defined. What is not well-defined? So, the sets which are not possible to explain, to determine, it is called not well-defined. Suppose she is beautiful, that is not well-defined. And yesterday, this is not well-defined. Therefore, it is the difference between well-defined and not well-defined. Generally, the sets are represented with capital letters, capital A, capital B, capital C, capital D, etc. The elements or the objects are denoted with small letters, lowercase letters, small a, small b, small d, etc. If x is a member of the set A, we'll write it x belongs to A. If x is not a member of set, then we'll write x does not belong to A. If both x comma y are the members of A, we'll write x comma y belongs to A. If x comma y is not a member of the set A, we'll write x comma y does not belongs to A. So generally, some sets we use to represent regularly is, suppose the set natural numbers, and the natural numbers are generally represented with the numbers set of 1, 2, 3, 4 like this. The natural numbers are denoted with capital N. I or Z is all the integers are denoted with capital I or capital Z. And the rational numbers are represented with Q. All the real numbers are represented with capital R. And Z plus is the set of all positive integers. And Q plus is the set of all positive rational numbers. And R plus the set of all positive real numbers. Hope you can easily understand this. These sets are generally used to represent the sets. Next one is, so how to represent the sets? There are two methods to represent the sets. One is roster form and second one is set builder form. What is roster form? So roster form is in this form. First one is roster form. Roster form. In this form, all the elements are taken and all the elements are being separated and enclosed within the curly brackets. That is called a roster form. Suppose all the odd numbers between 1 to 10 is, suppose n equal to set of all the odd numbers 1, 3, 5, 7, 9. Similarly, if you take a letter that is letter what? Letter is mathematics. Mathematics. So it is in the form we will write it set of M A T H A I C S. In this way we can easily represent any term in roster form. And so what are the merits of the demerits in roster form is first one is the first one. So in this form all the elements can be listed only once. So that is, suppose for example if you take A equal to set of 1 comma 1 comma 2 comma 3 comma 4. Instead of writing twice, we'll write it set of 1, 2, 3, 4. Similarly, and the second merit is the order of the elements is immaterial. Therefore, set of 1, 2, 3 will write it, and set of will write it 2, 3, 1, and will write it 3, 2, 1. So the order of the material, the order of the numbers is immaterial here. And what are the demerits? Demerits is, so here we cannot express all the real numbers in roster form because all the real numbers do not have any common property. And the second one, the infinite numbers also cannot explain in roster form. That's why we represent on set builder form. What is a set builder form? Set builder form is, in this form all the elements possess a common property or common characteristic is called a set builder form. So in the set builder form we use colon or slash as such that all the prime numbers between 1 to 10 is, will write it A equal to set of x such that x is a prime number so less than 9 will write it. Suppose one more example I would like to explain is set of 1 by 2, 2 by 3, 3 by 4, 5 by 6. So how to represent in the set builder form is, so b equal to x such that x is a natural number and so x equals to n divided by n plus 1. So in this way will represent a set builder form. And one more example is a comma e comma I comma o comma u. So we can easily represent in set builder form like this: x such that x is a vowel in English. So in this way, this is the common property which is possessed by all the elements. So this one. Next, how to represent? So what are the types of the sets and what are the characteristics? So first one is empty set or null set. The first one is empty set or null set. So the set which is not having any elements is called an empty set or null set or void set. Generally the empty set is denoted by empty brackets or pipe. For example, so if A equal to x such that 1 is less than x is less than 2, because and here x belongs to natural numbers. Is it an empty set or not? Why? Because we don't have any natural numbers between 1 and 2. Therefore, this is an empty set. And the second example is, so the square of any number is -1. So is it possible? If you square anyone, then we should not get -1. This is also an example. And next one is singleton set. What is singleton set? So singleton set. In a set, so if the number of the set is only 1, that is called a singleton set. So suppose set of A equal to set of pi. This is a singleton set. And set of 0 is also a singleton set. And second example is set of x such that x square minus 9 equal to 0 and x belongs to n. Is it a singleton set or not? Because if you solve this equation, we get x square minus 9 equals to 0. So x square minus 3 square equals to 0. X minus 3 into x plus 3 equal to 0. X equal to minus 3 and x equal to 3. Here minus 3 do not belong to natural numbers. Therefore 3 belongs to natural numbers. Therefore this set is a singleton set. But if you consider x such that x square minus 9 equal to 0, x belongs to integer. Here we are having x equal to minus 3 comma 3. This is not a singleton set because we are having two numbers here. Therefore, this is not a singleton set. And the next one is finite and infinite sets. What is finite and infinite sets? Infinite sets. So, if a set is having null and 0 elements and it consists of more number of elements, that is called an infinite set. Otherwise, it is called an infinite set. All the days in a week that is a finite set, and all the integer numbers are infinite set. So, and fourth one is cardinal numbers. Cardinal number. So, the number of distinct elements in the set is called the cardinal number, and the cardinal number is denoted by number of A. Suppose if a set is having A equal to set of 2 comma 4 comma 6 comma 8 comma 10 comma 12. Here we are having 6 elements. That equal to number of cardinality equal to number of A equal to 6. So if you take any letter, suppose accountancy, that means we are having 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Number of the cardinality equal to 7. In this way, we will explain the cardinal number. And the next one is equal sets. What is equal sets? So, if capital A comma capital B are two sets, and each element in a set A is a number of B, and each element in B is a number of A, then A comma B are called equal sets. Suppose, so if A is denoted by A equal to B. If A equal to set of 1 comma 2 comma 3 comma 4, and B equal to set of 4 comma 3 comma 2 comma 1, here we are having each element is in set A is a member of B. Therefore, we will write it A equal equal to B. If you take A equal to set of 1, 2, 3 and B equal to set of 1, 3, 4, here the two sets don't have any number of common elements. Therefore, here A is not equal to B. Next, after equal sets, equivalent sets. What is meant by an equivalent sets? Equivalent sets. So, if capital A comma capital B are two sets, if the number of elements in set A is the number of elements in set B, then A comma B are called equivalent sets. Therefore, it is written number of A equal to number of B. Suppose if capital A equal to 1, 2, 3, 4, here the set A is having 4 elements. The set B is having A comma B comma C comma D. It is also having 4 elements. Therefore, number of A equal to number of B. Therefore, the two sets A and B are having equivalent sets, and all the equivalent sets are equal sets, but the converse need not be true. Next, after equivalent numbers, and the next one is subset. Here, if capital A comma capital B are two sets, each element in set A is a member of B, then A comma B A is called the subset of B, and we will write it A is subset or equal to B, and B is called the superset of A, and we will write B is subset or equal to A. So here, suppose all the elements, for the difference between a set and an element, if X belongs to A, this is the relation between an element and a set. Here, A is subset. The relation between two sets is denoted with subset or equal to. And next one is proper subset. What is the meaning of proper subset? If A is subset or equal to B, and if A is not equal to B, then A is called the proper subset of B, and we will write it A is subset B, and B is called the superset of A. If a set is having the elements M, if number of A equal to M, then the number of subsets in set A is number of subsets equal to 2 to the power of M, and the number of proper subsets equal to to the power of M minus 1. And this is the main difference between subset and proper subsets. And what are the properties of proper subset? So, every set is a subset and proper subset of itself. And the null set is the subset of every set. So, and next one is, if capital A comma capital B comma capital C are three sets, next. And first property is A is subset or equal to B, and B is subset or equal to C, then A is subset or equal to C. And the second one is, if A is subset or equal to B, B is subset C, then A is subset C. And if A is subset B and B is subset or equal to C, then we will write it A is subset C. And if A is subset B and B is subset C, Then A is subset C. These are the properties of proper subsets. After proper subset, what is meant by power set? The power set. So, a ninth property is power set. Power set. The set of all the subsets in a set is called power set. The power set is represented with, it is denoted by P of A. Suppose if A is a set of elements having elements 1 comma 2 comma 3, then P of A equal to set of pi comma set of 1 comma set of 2 comma set of 3 comma set of 1 comma 2 and set of 2 comma 3 and set of 1 comma 3 and set of 1 comma 2 comma 3. So here, if the number of elements in a set is having n elements, then the number of subsets in power set is, so if number of A equal to n, the number of subsets in power set is P of A equal to 2 to the power of n. So next one is universal set. Universal set. If you take all the sets into consideration, then the superset of all the sets is called universal set. Universal set. So universal set, and it is denoted with U or mu. So if you take A equal to set of 1, 2, 3, 4 and B equal to set of 5 comma 6 and C equal to set of 6 comma 7, then the universal set equal to universal. The universal set is denoted with 1 comma 2, 3, 4, 5, 6 comma 7. Next, what is meant by disjoint sets? Disjoint sets. So disjoint sets are, if capital A comma capital B are two sets which are not having any common elements or numbers, then these two sets are called disjoint sets. And if A intersection B equals to pi, then A comma B are called the disjoint sets here. Next, so after disjoint sets, suppose capital A is a number, is a set having all the even elements. Suppose 2 comma 4 comma 6 comma 8 comma 10 and capital B equal to 1 comma 3 comma 5 comma 7 comma 9, and these are two disjoint sets because they don't have any common elements. So, and next one is explain Venn diagrams. What is meant by Venn diagrams? So, in order to explain Venn diagrams, in order to explain the relationship among the sets, we pictorially draw the diagrams. That is called the Venn diagrams. Generally, in the Venn diagrams, the universal set is represented with the rectangular region, and all the sets are represented with circles. This is called a Venn diagram here, and this is called universal set is represented with a rectangular region, and all the sets are represented with circles. Next one please. What are the operations of the sets and how does you clarify? Operation on sets means operation on sets. Next. First one is A union B. A union B is defined as a set which is having either the elements in A or B or both A comma B. That is called A union B. So A union B can be written as A union B X such that X belongs to A or X belongs to B. If X belongs to A union B, we'll write it X such that X belongs to A or X belongs to B. If X does not belongs to A union B, we'll write it X such that X does not belongs to A and X does not belongs to B. This is. If a set A is having A equal to set of 1, 2, 3, 4, 5 and B is a set is having 3, 4, 5, 6, then A union B can be written as A union B equal to set of 1, 2, 3, 4, 5, 6. This is A union B. So, next, in Venn diagram, it is represented with A union B is represented as here A, B, both the sets. So, that this is A union B. And the second operation in sets is A intersection B. A intersection B is defined as a common element in both in A and B. So A intersection B is X such that X belongs to A and X belongs to B. This is if X belongs to A intersection B can be written as X such that X belongs to A and X belongs to B. If X does not belongs to A intersection B, will define as X such that X does not belongs to A or X does not belongs to B. This is. So if a set is having, suppose for example, if a set is having the elements 1, 2, 3, 4, 5 and B the set is having 3, 4, 5, 6, then A intersection B can be written as the common elements. Here 3 is common, 4 is common, 5 is common. Therefore 3, 4, 5. In Venn diagram, we'll draw the picture like this. So here A, B. The common part in both the sets is A intersection B. Next, we'll discuss. Next one is difference of two sets. The difference of two sets is represented as A minus B. That is, so this is denoted by A minus B. if x belongs to a minus b is x such that x belongs to a and x does not belongs to b, this is the elements which are having in a and which are not having in b, this is called a minus b. For example, if a set is having a equal to 1, 2, 3, 4, 5 and b is a set having 3, 4, 5, then a minus b equal to set of 1 comma 2 is called the difference of the two sets a minus b. What are the properties of difference of the two sets? Properties are, what are the properties? That is, if a comma b are two sets and a minus b is not equal to b minus a and the second one is a minus b comma b minus a comma a intersection b are disjoint sets. Next, and third property is a minus a equal to 0, that is pi, and a minus pi equal to a, that is, in Venn diagram we can write, so here a comma b are two sets and a minus b is, we'll write it, this is a, b, a minus b, this is a minus b, and this is the difference of two sets. And next one is symmetric difference of two sets. Symmetric difference of two sets. And the symmetric difference of two sets is denoted by a delta b equal to a minus b union b minus a is called the symmetric difference of two sets, and this can be written as a union b minus a intersection b. This is the difference between the two sets. And next one is, if a set is having a equal to, suppose for example, if a is set of having 3 comma 4 comma 5 and b is another set having 3 4 5 comma 6, then so a minus b equal to, we will write it, a minus b is, so 1 comma 2 and b minus a is, that is b minus a equal to only this element 6. Then the symmetric difference between the two sets is a delta b equal to, that is 1 comma 2 comma 6. Next, complement of set. If capital A is capital U is a universal set and capital A is a subset of U, and the set which is having in U and which is not having in A is called the complement of A, and it is denoted with A dash, and A dash is written as U minus A. For example, if A is a set is having, if U is a set having U equal to universal set 1, 2, 3, 4, 5, 6 and A is 2, 3, 4, then and A complement is A dash equal to U minus A is, that is 1 comma 5 comma 6. This is the complement of set. Properties of complement of A. Complement of A. What are the properties of complement of A? If U is an universal set and pi is an empty set and U dash equal to pi, and the second property is pi dash equal to U, and A dash whole dash equal to A, and A union B whole dash equal to A dash intersection B dash, and A intersection B whole dash equal to A dash union B dash. These are the properties of complement of A. And next one is, what are the algebraic sets? Suppose algebra of sets. Suppose. Next one. What is meant by idempotent law? Means idempotent law. First one is A union A equal to A, and the second one is A intersection A equal to A, and the second one is commutative law. Commutative law. What is commutative law? In the properties, if A union B equal to B union A and A intersection B equal to B intersection A, and third property is associative property. Associative property. If A comma B comma C are three sets, A union of B union C equal to A union B union C. Similarly, A intersection of B intersection C equal to A intersection B intersection C, and A union of B intersection C equal to A union B intersection A union C, and A intersection of B union C equal to A intersection B union A intersection C, and A minus of B union C equal to A minus B intersection A minus C, and A minus of B intersection C equal to A minus B union A minus C. Next. If capital A comma capital B are two sets, then number of A union B equal to number of A plus number of B minus number of A intersection B. So if A comma B are two disjoint sets, then we know that A intersection B equal to pi. Then A comma B are two disjoint sets. Next, A union B, number of A union B equal to number of A plus number of B. And if A comma B comma C are three sets, A union of B union C equal to number of A union B union C equal to number of A plus number of B plus number of C minus number of A intersection B minus number of B intersection C, number of C intersection A plus number of A intersection B intersection comma B comma C are three disjoint sets, then number of A union B union C equal to number of A plus number of B plus number of C. In this way, we will solve all the problems.